In this set of videos, we're finally going to talk about how to actually find a solution to a differential equation. All right, so first we're going to talk about general solutions, which means we won't get an exactly specific answer. It'll still have some extra variables in it, but this is what we'll do. All right, so we haven't figured out how to solve any of these yet, but we're going to figure out how to solve one very specific type of differential equation. And the strategy we'll be using is called separation of variables, because we're going to just separating the x's and y's, and it only works for differential equations that are in this form. So we have our derivative, it's equal to an x part and a y part. And that's good because we want to separate this y part away from the x part to separate the variables. So here's the general strategy, and then we'll look at a bunch of examples. So it's called separation of variables. So we're going to separate the variables. We're going to move all the y terms to the left with our dy, move all the x terms to the right with our dx. All right, once you do that, then what you can do is integrate both sides. All right, so that's going to replace that derivative and turn it back to the original function. And then you'll get some equation that you want to solve for y. All right, this is going to be your general solution. All right, so let's look at this problem. Again, there's kind of an x part that's separate from the y part. I want to move the dx to the right, so I'm going to multiply both sides by dx. And I'm going to move the y stuff to the right, so I'm going to multiply both sides by 3y squared. So the dx's are going to cancel, the 3y's squareds are going to cancel, and I get 3y squared dy equals x minus 1 dx. So that's our separation of variables. We're separating all the y's to the left, all the x stuff to the right, and now I take antiderivatives, take the integral of both sides. So the antiderivative of 3y squared is going to be y cubed. Right, add 1 to the exponent, divide by the new exponent. X minus 1 is going to turn to x squared over 2 minus x. And then again, don't forget that plus c. All right, that's our second big step, is taking antiderivatives. And the last step is solving for y. So I just need to get rid of this y cubed to make it just y. So I take the cube root of both sides, because the cube root and the cube are opposites. So I get this as my final answer. All right, so that would be the solution to this differential equation. Of course, if you really wanted to, you could test this by taking its derivative and plugging it in and making sure everything works out. But generally for these, the answers are going to be kind of complicated. So as long as you follow along as you're solving it, this should be your answer at the bottom. All right, dy dx equals xy. Again, I'm going to multiply both sides by dx. In this case, I'm going to divide both sides by y. So I get dy over y equals x dx. All right, now that I've separated my variables, I take the integral of both sides. The integral of 1 over y is one of our special ones. We get the natural log of y. The antiderivative of x we just did is x squared over 2. And don't forget your plus c. Now to solve for y, so when I get this y by itself, how do we get rid of a natural log? I use an exponential, because those cancel. And that would be a fine final answer. A lot of times what you do when you have these exponentials with a plus c, you separate it into two separate exponentials, right? Because that's our exponent rules. We add exponents when we're multiplying two, and then e to the c is just another constant. So this is another way you might see it written. It all depends on how much they want to simplify for the answer if it was a multiple choice question. All right, this one, again, same thing. We're going to get the dx over here. And there's no y's on the other side, so we've actually already separated the variables. Now we can take the antiderivative. The antiderivative of 1 dy, 1 just turns into y. On the right-hand side, the antiderivative of cosine is sine. And I'm going to get a 3 there. All right, and that's the whole thing. Basically, just taking the antiderivative of 6 cosine of 2x, and that's your final answer. This is just kind of a thing to show you that sometimes there's no y term at all, and it's basically just taking the antiderivative of whatever expression you have. All right, we're trying to solve this differential equation. Again, the first goal is to separate variables. So I'm going to multiply both sides by dx, and I'm going to multiply both sides by cosine of y. I have to get the y's over to the left and the x's on the right. So on the left hand side, I'm going to have cosine of y dy. On the right hand side, cosine of x e to the sine of x dx. But once you've separated your variables, you take integrals. The antiderivative of cosine is sine, so it's going to turn into sine of y. And the antiderivative on the right is going to take me a little bit longer because I have a lot of stuff going on, but there's something inside of something else. So when I do my u substitution, so I make u the sine of x, so it makes du cosine of x dx, and dx is du over cosine of x. All right, so this is going to turn this integral into cosine of x e to the u, and then dx is du over cosine of x. So those are going to cancel and turn this into e to the u du. And the antiderivative of e to the u is just e to the u plus c. And then replacing u with sine of x. That's all that substitution we did to take antiderivatives just comes up in this problem on that right-hand side. Now I want to solve for sine, or sorry, not sine. I want to solve for y, so I need to get rid of that sine. So the way I always do that is just use its inverse. So I'm going to take the inverse sine of both sides. And that's going to give me my final answer, because now those are going to cancel, give me y. If I remember from when this was written for the multiple choice questions, they actually use arc sine. So it doesn't matter which sine you write, but just know that sine inverse and arc sine are the same. And that is your solution to this differential equation. So just showing this one because, yeah, there's sometimes when you're doing a differential equation and you still have to do that substitution stuff to get your antiderivative. All right, so here's one for you to try on your own. All right, figure out the solution to this differential equations. All right, so go ahead and pause the video and we'll come back and show the solution. All right, and when you solve all the way, you should get something that looks similar to this at the bottom. So separate our variables, all right, y's on the left, x's on the right. Take antiderivatives, right? Y turns into y squared divided by 2, so you get 2y squared. Antiderivative of cosine is sine. And we're trying to get y by itself, so the first thing I do is divide by 2 to get rid of that, and then take square roots to get rid of that exponent. All right, so this is the only way that we're going to know how to solve differential equations in this class. All right, so if you see that you have to solve a differential equation, just automatically know, separate the y's and x's, and take antiderivatives.